I welcome you back on the second part of that conservation of linear momentum. This possibly is the last one inside the text. After that, only textual questions and all remaining. Here, we want to prove that the momentum, linear momentum, is constant, not changing. Okay, how to prove it? First, we'll take the two masses A and B. A and B, their name will be A and B. Okay, their names will be A and B. Let me call it A, let me call it B. This is A, this is B. See, these three diagrams I have made. What is the meaning of this? Let M1, you can write these things, okay? Let M1 and M2 are masses of object A and B. So this is A, this is B. Now, U1 is what? Velocity, speed. With this velocity, this mass may be a ball moving this direction. Another ball is there, B, mass U2, this moving in this direction. What will happen if two objects are coming to each other? They will hit, collide. Second situation is this. Before some time this was happening, just after some time this happened. They collide with them. Okay. After collision, what will happen? They did not stop. They recoil. They again recoil back. That means it has gone again this direction. It was coming from here, hitting and again going back. Okay. This happened. The velocity change. Earlier it was U1. Now it becomes V1. V1 means why? It is final. Symbol of V is final, U is initial. 1 means object A. Similarly, V2 is, U2 has changed from U2 to V2. So this happened. Here I wrote what are these things, only symbols. U1 is initial velocity of M1, U2 is initial velocity of M2. Okay. Now what I'll write here, after time T, let, this means after collision, okay? Collision takes place after time T and this happens. Let V1 is final velocity of A, or I should write M1. You can write A also. V2 is final velocity of M2. Okay, so what I'll write it here now is that initial momentum of A. What is that? M1 U1. Why M1 U1? Because the formula is mass into velocity. Mass, early velocity. Early mass, early velocity. M1 V1 U1. Now similarly, initial momentum of B, M2 U2. M2 U2 before collision. Okay. After collision, here nothing happened. Here the things will happen. Now here at the right is the rate of change of momentum. Why I wrote this? Because we know this is the thing from the second law. What is the rate of change of momentum? FAB is equal to M1 before this I need to write some more. Rate of change of momentum, just this, okay. Final momentum of A, M1 V1 here, M1 V1, okay, final after collision. Similarly, final momentum of B, M2 V2. Now we'll write the rate of change of momentum in each of the object. What is the first one? For A, rate of change of momentum during the collision for A. For A will be FAB. Rate of change of momentum is force. We already know this from the Newton's second law. So what is this? M1 V1 minus M1 U1 divided by T. How do I know this? Final. minus initial. Okay, so this gives me m is common, v minus u1 divided by t. This is rate of change of momentum for A. Now also rate of change of momentum for B. What is that? FBA. How do I know? It's also second law. Second law says that rate of change of momentum is force applied. So what is force applied on B? Due to A. Because of A it collided. E came and hit the B. B also will say same thing. A came to me and hit me. So that is why force on A due to B, force on B due to A. So force on B due to A is rate of change of momentum on the second object divided by T. Now take common just like this. This will be equation 1. We'll use the third law also here. About to finish. Continue it from there. Okay. BA will be equal to M2 is common, V2 minus U2 divided by T from third law. What we know here, FAB is equal to minus FBA. They are equal and opposite. Okay, force on A due to B and force on B due to A, they are exactly equal and they are opposite in direction, so the minus sign came. Remember in the earlier one I did not put this minus sign because I was using the vector sign there and I was not worried about the direction. I was just showing you its value. They are exactly the same. Okay, but when you use in practical examples you need to show that it is opposite in direction also. From 1 what I get, m v1 minus u1 divided by t. From 2 what I get, m2 v2 minus u2. T and T in the denominator will cancel. M1 V1 minus M1 U1 equal to M2 V2 minus M2 U2. Bring them to the positive sides. M1 V1. Okay. I left this minus sign here. Okay, this minus sign was there. This will make it minus, this will make it plus. Okay, this is already cancelled. Minus into plus is minus, minus into minus will be plus. M1 V1 here, I'll bring it here, plus M2 V2 equal to, I'll bring it there, M1 U1 plus, already there, M2 U2. What does this mean? Momentum of the first object, momentum of the second object before the collision. After the collision, this. They are exactly same. That means they interchange their, change the velocity little bit among themselves little bit. U1 become V1, U2 become V2. But total MV, if you add them all, they still remain same. So this is initial momentum is still same as final momentum. This is conservation of momentum proved using second law here, here and third law here. Okay, this is all. Thank you.